Now we'll be solving question number 12 from exercise 2 of the phase 1 chapter called laws of motion. Let's see. The two objects A and the B are thrown upward simultaneously with the same speed. So I'm throwing two objects with the same speed in the upward direction. Let's say the speed is u. The moment you are throwing them, you will see some acceleration in the downward direction. Now, the mass of A is greater than mass of B. So let me call this as A mass M. This is B mass MB. And according to the question, M is more than MB. Suppose the air exert a constant and equal force of resistance. So when they're going up, there is an air resistance as well. Let me call that air resistance as FR. R is stand for resistance, and this is constant. FR is constant in both the cases. Now they're asking among the four possible options, which is going to be the right option. Okay, let's see. So let me make the FPD. The options are like the two bodies will reach the same height. So meaning H, A will go higher than B, or B will go higher than A, or any of the above three may happen depending on the speed with which objects are thrown. The speed is same. So obviously that's not the thing we are looking after. So out of the four options, which is going to be right option, it will be depending upon the acceleration. Okay. So let me check what is the acceleration in this case. So when we are throwing the body up, mg will be acting downward direction. Right now, I'm not putting A or B. I'm just going general case. At later stage, I can replace the M by MA and the MB. Throughout the motion, there will be force, resistive force, which is constant in both the cases, FR, that is also in the downward direction. It is downward because the bodies are going up. When the body will come down, at that time, the FR will become in the upward direction. So these two are the forces when the bodies are going up. And so since both the forces are in the downward direction, so we'll see the acceleration, or you can see retardation in this case, will be in the downward direction. Let's calculate. So direction of acceleration, we take it as positive. So downward is positive. Mg plus Fr, that will be equals to M into A. So acceleration will be equals to G plus Fr upon M. This is the acceleration we are getting. Now you can check. Acceleration is inversely proportional to M because G is same in both the cases. So we know that MA is more than MB according to the question. Then we can say 1 upon MA will be less than 1 upon MB. Or we can say G plus 1 upon MA, G plus FB upon MA will be less than G plus FB upon MB. Or we can say acceleration of A will be less than acceleration of B. This is the relationship we are getting. So from the given information, we have got the relationship between the acceleration. We have not got the exact values, we have got the relationship. Which acceleration is going to be more or which acceleration is going to be less. So let's talk about the height. Because if you see, option A, option B, and option C, they are talking about the height. So I want to make a relationship between the height traveled by particle A and particle B. For that, I'll be using the third kinematical equation. So from third kinematical equation, we have V square is U square minus 2A delta S, or you can say H. I've taken the minus because it's a retardation. In this case, it was retardation happening. So at the maximum height, both of the particles will have the zero velocity. According to the question, both the particles are traveling with the same speed. So we'll get at the maximum height, it will be 0 U square minus 2A into displacement. And I'll get the displacement as U square upon 2A. Now, if you use this relation, here the height is inversely proportional to acceleration. So since acceleration of A is less than acceleration of B, and this is an inverse relation, so I can say the height traveled by A will be more than height traveled by B. One more time. This was the question about the height traveled by A and height traveled by B. We know height traveled will be depending upon the individual accelerations. And individual accelerations will be depending upon the individual forces. So first we went with the FBD to calculate the force, using the force to calculate the acceleration. So the mass relation, from the relation between the mass, we got the relationship between the accelerations. Once we got the relationship between the accelerations, then we went for relationship between the height in terms of acceleration. And from here, we got the relationship between the height. So it's an indirect approach we have followed. And we got the relationship between the height traveled by A and height traveled by B. And height by A is coming more than height by B. So second option, if you see, which is saying A will go higher than B, is the right option in this case. Okay. So sometimes we have to go indirect, because when the examiner is giving you a question, his objective generally is to check whether he can manipulate one information to other or not. Okay. I hope you understood this. Thank you.